Here we go. I'm going to go ahead and continue with what we were working on yesterday. The exception that we didn't actually go through any of these yesterday other than you doing the one on your assignment. Okay? So, my first step involved here is to do what?
Put it to log format.
Good. Hey, yeah, take the natural log. So you guys, if the variable, the rule you need to get down, if the variable's in the exponent position, you need to get it out of there. And there's a couple ways to do that. One is to write it in log format. Okay? So in this case, since this and that, those bases aren't the same, I'm going to write it as log. So this is x now is equal to the natural log of 2. Or x is less than natural log of 2. And that means x is less than, what is the natural log of 2? 0 point what?
693,000.
Good, 693,000. So x is less than 693,000. Okay? Now same thing on here. Base 10, base 3, not the same base. Therefore, we are going to get that out by writing it as a log.
Oh, it's a common log.
It is a common log.
Oh.
And then from that point, it's just like an equation. Add 6, divide by 2. So if we add 6, okay, and sometimes it's helpful for students to actually see, or anyone working with them for that matter, to actually see that that is together. The 6 is not part of that. So you can insert your own parentheses there. Okay, and then when we divide that by 2, I'm going to have to do that up here, but we'll have x is greater than, thank you, x is greater than the log of 3 plus 6, all divided by 2. You can't just divide here, right? You'd actually have to, in order for you to deal with this, you have to divide that by 2 and that by 2. So if I'm putting this into my calculator, this is the part I'm going log 3 plus 6, and then all divided by 2. So x is greater than what?
3 and 239,000.
All right. Hallie. Yep, that would have been fine. For sure. Okay, any other questions there? Number 9. Or number 11, excuse me. So it's helpful sometimes to, like I said, put parentheses around the log. Please note that that right there, I'm going to erase this top part so it is not confused with that. Okay? That part right there, it's log of x. It is not log of x plus 9. In order for that to be the case, you'd have to have parentheses like that. If you don't see parentheses, then you are just taking the log of the immediate number after, or letter. So I'm going to put parentheses just so I see, well, man, that just means I subtract 9. Okay? So that means log x is less than 36, which gives me x is less than, move that over, right? 10 to the 36, which is a huge number. So I'm going to just leave it as 10 to the 36. Okay? Because that's like 1 with 36 zeros, right? I don't want to write that. Yeah, just for fun. Yes, you go ahead. All right. So, is that my answer? Well, there's one extra piece here. Whenever you have a log, you better add that extra piece. Can this be 0? Can that be negative? Okay, let's make it a little more clear. Let's just take the log of x. Okay? Log of x, what is that? Well, let's just say, all right, I'm going to write that as in exponential form. Let's just write it in exponential. That's 10 to the... Okay, let's do this. Can it be 0? Well, that would mean 10 to the 0 equals... If I move this over, equals x. So it could equal 0. Can x be 0?
Oh, no.
You sure?
No.
Let's switch our variables. So now we're saying, could it be 0? So maybe we should use something other than x. Let's use y. Okay? So now I'd have 10 to the y, or not. Can I do what? Oh, yes, I could. I'm sorry. Yes. 10 to the y equals 0.
I have no clue now. You're just like blowing my mind right now.
Hey, can you raise anything and get to 0?
No.
No. Okay? How about a negative number? Negative 1. So that means the other part of this problem, x has to be what?
Greater than 0.
X better be greater than 0. So meaning you have two rules here. This is saying it's less than 10 to the 36, which includes every single number less than 10 to the 36, which means all negative values and 0. Okay? So we have to restrict that and say, well, you could go to here, but it still has to be greater than 0. So if you're writing that out, which one's bigger? Bless you. Bless you. 10 to the 36, 0, and we have x. It has to be bigger than 0, less than 10 to the 36. Okay, so anytime you're taking, notice you didn't have to do that here because you can have a negative power. Anytime you're dealing with logs, though, you have to deal with that. So we're going to have to deal with it here?
Yep.
Yeah. Potentially, right? Put those parentheses in. That's 2 times that minus 1 greater than 4. You think of it this way. For those of you who are like those parentheses, really it's kind of the same thing as doing this type of problem. It's the same steps except for the last step. Add 1, divide by 2, right? There's 2 steps there. So if I add 1, I get 5. And I divide by 2, get 5 halves. That's going to get the natural log by itself. So the extra step you have to do is write it exponentially. E to the 5 halves. What is e to the 5 halves? Good. So does x have to be greater than 0? Do I need this? Tell your neighbor why you don't need that this time.
It's already greater.
Okay, 12 is already greater than 0. Therefore, you don't have to put it. It would be redundant. Not to mention, you would actually be adding a bunch of values in between 0 and 12.182. Or 12 and 182 thousandths. Okay. Questions? Okay, I want you to take out yesterday's assignment, and compare your answers for 1 through 3, please. Show your neighbor what you got.
It is not
Compare your
Monday
work.
yet.
1 to 3. We're going to take this step by step. Okay, here we go. Number 1. I'll put up the answers. You can kind of check them out. And we'll go through questions on them. Okay? So the first one. X equals 4. I'm going to try to give you some guidelines to follow as we're going through this, so just make sure you're making notes to yourself. Okay, so first, you look at these in exponential form. If they have the same base, keep the base and just set your exponents equal. That's all you're doing there. Base is the same, therefore the exponents have to be the same, or the powers have to be the same. So you have 2x plus 4 equals 5x minus 8. You solve x equals 4. So recognizing that first. Any questions on 1? Number 2. Note to yourself, well, I look at it and the bases are not the same. Question becomes, can I make them the same? So like if you're writing yourself notes, first, are the bases the same? No. Can I make them the same? Yes, they're both base 2. By base 2, that's 4 squared. 4 becomes, is 2 squared. And 8 becomes 2 cubed. And once you have the same base, then you're back to just comparing the powers. This equals that. Make sure you put parentheses around the outer part. And then solve. X equals 8. Fun stuff. Yeah. Any questions on that one? It's your desk. Yeah. She helps our algebra students. Okay. Any questions? All right. Number 3. The answer, by the way, is negative 1.54. Looking at them, same questions. Are they the same base? Can you make them the same base? No. So now you have a new thing you have to do. Are they the same base? No. Can you make them the same base? No. That brings you to another thing. You now need to impose the log. So if you're writing yourself notes, make those notes to yourself. Okay? Yes? Yep, you could do that. Yeah. Yep. So there are other ways to go. I'm just going to go one method for those that are struggling. I'm not going to give multiple approaches, but you could do that, yes. Okay? So impose the log, and then from there, make sure to bring this out by applying the power property. And then divide by log 3, which, Emma, that would have brought you to right here. Okay? And so now you're at x equals log base, or log of 5 over log of 3, all minus 3, subtract 3, gives you negative 1.54. Emma, you want to say what you did again? That way, if anyone else did that, they're not thinking they're doing it wrong.
Yeah, so what I did is I took like the 3, and then I just did that arrow thing where you move it over, and then I got log 3 of 5 equals x plus 3, and then I did the change of base thing, so I had log, the common log of 5 over the common log of 3, and then I just subtracted the 3 and put that in my calculator.
Okay, and that jumps you to this step. So it kind of, you get to skip a step or two there if you do that. which is completely fine. That if that works better for you, use that. But if you're like, yeah, I don't quite get it, then make sure you just impose in the log. Okay? Good. That's by the way, doing this, you skip a step in there. Like you do it in one fewer steps. So okay. So we could put or there. Number 4. Tell your neighbor what you got. 4, 5, and 6 actually. As far as you could.
Huh? I didn't get the next one.
Okay. Let me go ahead and put up the answers and we'll go through questions. So first, number 4. Let me erase a piece that I had earlier there. Okay. So on number 4, looking at it, are they the same base? Can they be made into the same base? Yes, you have a 5 and a 25. They're both base 5. This is 5 to the negative first. This right here, it's good to rewrite it to begin with as 25 to the 1/2 x. Okay? So rewriting it in exponential form is helpful. I get rid of those radicals right away, not because I don't like radicals, but because it's easier in exponential. And so when I rewrite it, 5 to the negative first, 3x minus 2, and 25 to the x over 2, so combine these, that's just x over 2. And 25 is actually 5 squared. And so now you've made the same base. By making the same base, you set them equal. And you set your powers equal and solve, you get x is 1/2. Questions? Notice I keep trying to repeat the same questions to myself every time I approach a problem. Okay? They're the same things I ask myself. Yeah? I've got to take the negative 1 that's here and distribute it. So negative 3x, positive 2. The x, that's 2 times 1/2 x, or 2 times x over 2. The 2's cancel, just x. Yeah? Yeah. Okay.
So even though they're the same base, they're 2 different powers. So what do you do with those powers?
These are the powers, right?
Yeah.
So as long as they're the same base, you can just set the powers equal.
Why?
Because if I say 5 to the second power is equal to 5 to what power? The only, like this is 25 here. This value over here has to be 25, right? So what makes this 25?
Oh.
Dude, the powers have to be the same. That has nothing to do with this problem, but that's kind of the premise you're using. Other questions? Okay, number 5. What's the first question I'm asking? Are they the same base? No. Can you make them the same base? No, it's base E. Okay, the first thing though, I should really get the base by itself here. So I have to divide by 12, and then I probably should ask that question. Now, are they the same base? No. Okay, can I make them the same base? No. So at that point, I need to write it in log form. I'm going to bring this over. That is the natural log of 512 is equal to 1 minus x. Okay, so it's really the same process. From here now, I subtract 1. Please note I put that in parentheses, and I haven't done anything with it yet. When I go to the next step, I subtract 1. You could have put the 1 minus at the back, the minus 1 at the back, and then divide by negative 1, which flips that sign to positive and that one to negative. And then actually put it into your calculator. X is negative 2.73-ish. If you're leaving it in exact form, you'd have to leave it in this form right here. Can't simplify that anymore. I'm waiting. Yes? Yeah. It's pretty close, but it's not. Yeah. Okay. Questions? Number 6, go into the same questions. Well, first, let's get the bases by themselves. So add 14. You now have two things. Base E. Well, actually, you should divide by 3 first. There we go. Base E and, well, that's not base E. Okay? So what am I going to do? Write it in log format, which is natural log. This one seems easy now after all those others. 2.12. Make more sense? Oh, ask the same questions. Are they the same base? Can I make them the same base? And if not, write it in log. Okay? Those questions, those steps. All right. Number 7 through 9er. Compare them. All right, number 7. Okay, so on number 7, we're in log format. The variable is in the log. So to get the variable out of the log, first you look at this side and say, well, is there a log over here? No. So if they were both the same log, then you could just set the parts equal to each other, the thing you're taking the log of. Okay? For instance, on number 8, when I look at that one and approach that one, log and log, they're both base E. Therefore, this must have to, or that this must equal that. Okay? Whereas in this problem, log base 3, and now we have a 2. That is not log base 3, obviously. Therefore, to get rid of this log and get the exponent or the variable unlocked, to kind of unlock it, you have to write it exponentially. Yeah, unlog it. Yep. Nice. Okay. So we have 3 squared equals 4x, and then it's 9 equals 4x, so x is 9/4. Okay. So are you taking the same log on each side, the same base? Once again, is it the same base? No. Okay. Can you make it the same base? Well, technically you could try that. That's very tough. But so probably the answer would be no. Then write it exponentially. Okay. So going to number 8. Is it the same base? Yes. Therefore, this must equal that. Okay. You guys, if you can relate this to what we did up here, like on 1, is it the same base? Yes. So therefore, that equals that. Is it the same base? Yes. Therefore, that equals that. Now you just have a x squared minus 1 equals 0. X is plus minus 1. Anytime you get a negative number, I mean, you should test every number, but especially a negative. Make sure you don't have x by itself. So here you're squaring that negative to get a positive. And adding 3, it's going to give you a positive number in the log. Questions on 8? Okay, number 9. Same base. Can you make them the same base?
Nope.
Probably not. Therefore, write it as an exponential. Move that 8 over. So now you have 8 to the 2/3, x squared minus 5. 8 to the 2/3, cubed root of 8 is 2, squared is 4. Add 5, take the root, plus minus 3. There's a negative again, always just double check. It works out, we're good to go. Questions there? All right, I'm going to kind of hit number 10 and 11 right now without having you guys talk about them, because those were a little tougher. Number 10, let's go through the questions. Are they the same base? Yes. Okay. Can we can't just say this, like if it was that, it would be easy. We'd just say x plus 2 equals x plus 6, and we'd solve. However, we have this added piece here. Therefore, we have to apply one of our properties. What property? The product property. Multiply them. This times that. That combines it to a single log now. Or single natural log. Okay, and now that you have one natural log on this side and one natural log on this side, they're the same base. Now that equals that. And then from there, you just have a simple quadratic. I mean, a couple months ago, simple quadratic didn't exist. Now you're like, oh, thank goodness for a quadratic. No logs? Man, that's great. X squared plus 2x. Get it set equal to 0. Factor and solve, just like the good old days. Please note, you get a -3 as one of your answers. Which one doesn't it work in? Does it work on this one? Yep. Does it work here? Nope. It gives you a -1, and here, nope. It only has to not work in one, so that one is no good. Yeah, you should really test 2 also. I mean, if this was like x minus 4 and you put 2 in, that would give you a negative. So just because it's positive doesn't mean it's always going to work. Better double check. Yeah. Same thing that we did at the beginning with any kind of log. Any questions on that one? How many are more clear on it? Same questions we keep asking every time. So, number 11. Same base? On 2 of them. No here. Okay, so if we're dealing with the 2 that are the same base, they're on the same side, what property? Good, the quotient property. Okay, divide them. And now you get down to 2 things. This thing equals that. Same base? Nope. If it's not the same base, then you have to write it in the other form. That would be 2 to the 3rd equals x plus 5 over x minus 2. And 2 to the 3rd is 8. Now, just so you know, this is next chapter. We will do a lot of these next chapter. They'll look a lot more fun, though. Okay? That's called a rational function. It's very fun. Okay? From that, I would cross multiply to solve. So that gives me 8 times the quantity x minus 2 equals x plus 5. It's just a proportion, right? And then that's 8x minus 16. Move your 8x over, you get -7x plus 5 equals -16. Subtract 5, you get -21, and x equals 3.
Did you make it a quadratic?
Nope. Not on that one, yeah. Okay. Put the 3 in. It works out. You're good to go. Andrew.
On the fraction part, where it's like x plus 5 over x minus 2, all you're doing is just multiplying it by x minus 2 again?
Right here?
Yeah.
So here I'm cross multiplying. That times that, that times that. Yep. Yeah. Okay. Any questions there? Okay, number 12, we already did a bunch like it, so I'm just going to give the answer, and you can check it if you'd like. Just make sure you have that part where it has to be greater than 0, right? That's the piece we didn't talk about until today. We have to make that greater than 0 because we can't have a negative or a log that's 0 or smaller. A negative or a 0 log. X, or 10 to the 1/2 is square root of 10. You didn't actually have to show that. You could have just went. Yeah. You could have put 10 to the 1/2 there. Number 13. I'm going to give the answer. I'm not going to spend tons of time on it. I will walk through it just really quick. But the temperature we want it to be, the new temperature, is 63 degrees. Or how long we're seeing, how long it will cool. It'll take to cool to 63. The original was 80. Okay, the room temperature is 60. And then E, R, they're telling you is that. And then T is time, which we're solving for. And then room temperature is 60. So you move that 60 over to get 3. You divide by the 20. You then take the natural log and divide all of that by the negative 0.147 or 147 thousandths. And you get 129 and 600. Okay, minutes. Now, that's Newton's law of cooling. Okay, if you don't like it, take it up with Newton. All right? Yeah. Well, it'd be tough, but some people. Okay. By the way, the bottom one, talking about the Richter scale, that is the work involved there. Okay. You could have picked, if they're saying it had, in the same year, another earthquake had intensity 4 times stronger. I just said my intensity, I replaced I with 1, which made that 4. You could have said 2, and that would be 8 then. Or either way, eventually you would get an answer of 8.4 on the Richter scale. Okay. What's that? 10 to the negative 7.8 power. Right here.